Blazor WebAssembly with a single web API.
You are programming with Palermo. You deliver software. You need to move fast, deliver quality, and run your software with confidence. Stay tuned for timeless solutions, simple methods, and topics that will propel you forward. And now your host, lifelong programmer, author, teacher, coach, Christian, and charismatic speaker, Jeffrey Palermo.
Welcome to Programming with Palermo. I'm Jeffrey Palermo, and we're going to talk about Blazor today, specifically Blazor WebAssembly, and how to avoid this huge proliferation of web APIs, web services, calling back from your Blazor application, which is running in your browser, back to a server. Every other technology for remoting over a wire has some way to establish a connection, but have multiple reasons for going over that connection, in any unlimited number of going over the connection. But Blazor WebAssembly, the default pattern, leads us to a situation where we have a proliferation of web service endpoints. And we're going to talk about that, give you a pattern for how to limit those web services when you are running your own Blazor WebAssembly application, your own server, and you're not publishing out to the world. So let's dig in and start with an architectural diagram. We are going to start with code on the GitHub repository. You can go to github.com/Jeffrey Palermo, and this one is Blazor WebAssembly, Blazor WABM, single web API. But let's go to an architectural diagram and let's talk about this. So with Blazor server side, a user does some things, calls to the browser. The browser is just running blazor.js, and blazor.js has a single connection back to the server, which is over a open WebSocket, and it just has one address, and it keeps it open the whole time. And the server, likewise, has one connection, one transport to its database, SQL Server database, or whatever database it happens to use, or any kind of data store connections. There is a single address and a reason for connecting over to the database, no matter any number of queries that may be sent. Likewise, no matter how many pages you have, no matter how many button clicks you have from the Blazor server-side application going back to the server, you have one WebSocket connection, one WebSocket address that stays open, and lots of different data messages go back and forth from the browser to the server. The default pattern for Blazor WebAssembly is very different. Your own .NET DLLs are running in the browser. Your code is running in the browser, and the default pattern is to encourage us to use web services with Web API over to the server. But the default pattern for Web API is to create different Web API controllers for each reason to call over to the server. And so if this was SQL Server, it would be like having one connection string per query. With Web API, we create another controller when we have another reason to ask the server for something or to tell the server to do something. That's queries. Conceptually, we model it as queries and commands. Okay. Now, that's kind of messy. And if you're creating web services for customers or for the public, you're going to use Swagger, and you're going to document the APIs, and you're going to want individual endpoints and give some people access to some and some people access to the other and all that. And that's great. But that's a lot of overhead and a lot of just clutter and unnecessary complexity whenever you have your own Blazor WebAssembly application and your own server-side application, and they just need to talk to each other, and no one else is ever going to use those web services except for me. Why do I need to document it? Why do I need to have the Swagger documentation? I don't need any of that stuff. Really, I just need a way to call to the server. I really don't even need HTTP. I really don't even need JSON, XML. I just need to communicate, have some way to communicate with my code running on my server. And so having multiple Web API controllers, that's really a lot of clutter. And so let's talk about a different architectural pattern that that really leverages all the other remoting technologies, and that is by having one address on the server, and we can send as many queries, as many commands as we need to through to that single address, to that single conduit, single transport, and be able to use it and talk back and forth. If you think about it, when we use Azure Service Bus and have a queue or a topic and subscription, those topic queues, we have one queue and we can send any number of messages to that single queue. And on the back end, we have some code that's processing any of the messages that happen to come from the queue. And it's the message handler, the process that's watching the queue, it's that code's responsibility to look at what the incoming message is and route it appropriately so that we can handle it. So we're going to use some of the same patterns here with Blazor WebAssembly so that we don't have this big proliferation of web services. Because if you think about it, your Blazor applications, any of these applications as they get larger, you're going to have a large number of screens. And each of the screens is going to have an initial load of data, probably a few subsequent loads of data for small different areas. You're going to have some button clicks for some commands to tell the server to process a transaction. And so you're going to have several reasons to call back to the server for every page that you happen to have in your application. And you're just going to get crushed with the number of web API controllers that you start to amass. And why? It's just additional ceremony. So we're going to refactor that down and get to a single web API for our Blazor WebAssembly application. So let's get into the code sample and look at how that looks. I'm going to, first of all, give you just a quick demo of the application. Again, you have full access to the code on GitHub. But here's my application. I'm just gonna run without debugging, Control F5 right here, and it's actually already open. And there we go. If I go to home, I'm going to come back to this later, but we actually did call back to the server for that. I'm going to go to counter and I'm going to count. Now I'm processing this on the client, which I'll show you, but I'm actually processing this math on the server. So I'm taking an excuse to call back to the server. And for fetch data, I'm loading data, getting from the server, got it. But if I click on one of them, let's click on the bottom here. Click on it, simulating getting additional data. Watch this bracing when I hit update. Update, there I've updated it. All right, now let's show you that I'm actually calling back out to the server. So if I pull this over, and just do a refresh. Notice that we called to the server. I'm going to kind of clear this out and hit home. And notice that I called a web service endpoint called Blazor WASM Single API. And we can see that the payload was some JSON and the response was some information. But actually, I'm going to go to counter, do the same thing. Click, 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 click. Each of these is a call over to the server, and the payload was count 7. That's what it is, 7. And I'm going to click and see, we can see count 8. And so we're passing the current count, and the server is adding 1. Then fetch data, we want to load that, and let's look at the response. I'm just going to copy all this JSON so that you can see what we're receiving back. Go to the VS Code JSON visualizer, and we're going to look at it in the JSON viewer just so we can see it prettified. We can see that the data that came back from our web service was an array of weather forecast, and you can pretty much see this is the weather forecast data that's coming back. All right, now that we have that out of the way, let's kind of go through the different elements of the code. All right, let's look at the single controller first. So you can see where that is. It's in our server project. The structure of the projects, I pretty much use the vanilla templates right out of the box with some changes. For the web API controller, it's inheriting from controller base, and the address is actually a constant. Let me jump into here with Control B with my reshuffler shortcuts. And I'm going to come back to this publisher gateway in our shared project later, but I have a application-wide constant that is going to be the address of the server for the purposes of the web service. So let me come back and notice that the API controller, it really only has one method with a post, and it is going to receive a web service message. Now, if you've used any of the other transports like SignalR or Azure Service Bus, this will look very familiar to you. Actually, with Azure Service Bus, the SDK uses a service bus message, and it's built into the SDK, built into the .NET DLL that you're going to use. If you're using Azure Service Bus queues or topics, you're going to use a service bus message. And service bus message actually is the envelope with it that the data gets stuffed into. So for this pattern, we're just creating our own envelope, web service message. And so what we're going to do is we're going to receive a web service message, and then we're going to get the object body. And of course, if it's null, we're going to throw an exception. We're going to send it down our bus. I'll come back to this bus pattern in a second, but every application needs some type of bus, some type of hub and spoke architecture where you can take messages of any particular type and send them to an abstraction, send them to a particular endpoint, and then there's some type of routing logic that fans them out and routes it to a particular handler. Web API does this for us. We're sending HTTP messages to this relative URL, and the framework is actually routing it to this particular controller object for us. So that's one example. And then there's other frameworks like In-Service Bus and Mass Transit that listen to Azure Service Bus and decide what handler to route those messages to, and it's all over the place. Hub and spoke architectures are all over the place. So we're implementing one instance for ourselves here, and we're going to get back the result of this being processed, and then we're going to take the result. We are going to instantiate a new web service message. We're taking the result, we're stuffing it in our envelope, and then we're getting JSON, which is the format that we use to send it back via a web service. All right, so that's how it happens. Now let's look at the caller. Okay, this is the server side. Let's look at the caller. So this is our client application, and of course, our client application has an app settings program. The program is pretty simple. We don't have a lot of new things except for this section here. So to get this application running, we're going to have a base address of the HTTP client, just so that it's kind of baked in. We are going to add Mediator, which is one of my favorite libraries that helps me implement a bus pattern. I like to take the Mediator library, which uses generic-based dispatching to individual message handlers, and I like to wrap it up for a custom bus implementation so that I can have a single conduit. It's always good when using third-party libraries, open source libraries, to wrap it with your own code so that you have some method of indirection before you get into code that you really don't control. We're also adding a class called Publisher Gateway, which I'll talk about in a minute. And on the client side, we are adding a remotable bus as our iBus implementation. And I'm going to get back to kind of that in a minute. And then a remote bus URL, which is in appsettings.json. And of course, this is where appsettings.json goes in a WebAssembly application. Open that up. And notice this is the URL of our server application. Deployed to a non-local host environment, this is going to be wherever your web server is. Okay, so let's kind of trace through what's happening. So the simplest is counter.razor. And notice that we're going to increment right here in the browser. We're going to take the current count. We're going to implement it. We have the current count displayed here, and then we're going to have a server-side return value displayed here. But in order to get that, we are going to create a new counter query, and we're going to send it down our bus, which is an implementation of the bus interface, iBus. Okay, what is this counter query? Well, let's go over and see where these are. In our shared folder, we have queries. All right, counter query. Now this is a very simple object. We're using C# records because it's a type of class, but it's really just a data transfer object. It's just meant to be a holder of a concept, and so that is perfect for records, because records, when they are compiled, they compile into classes with some interesting semantics that are useful in this instance. So we have our counter query passing in the initial count, which ends up being a property, and this implements iRequest of server count, which is going to be our return value, and it also implements a marker interface that our bus is going to use for some intelligence called iRemotable request. That means that this counter query can be used inside our code in the browser, but if I ask for this counter query to be processed, to be handled, that marker interface is an indication that it's remotable and is going to be handled on the server as opposed to just inside. And of course, server count, that's the same type, and that's going to be the information that we get back. We're going to get back the new count, and just to demonstrate that we can pass any arbitrary number of pieces of information, we're going to get back the server process name.
Programming with Palermo is brought to you by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient, moving fast, delivering quality, and running their software with confidence in Azure. If your team has a project that's too important to be delayed or derailed, ClearMeasure can help, while keeping your team in the driver's seat and growing in capability. Click on clearmeasure.com for more information. If you are an architect or .NET engineer aspiring to become an architect, check out clearmeasure.com/careers. Now, back to the show.
Okay, so come back to here. So the return value is whatever the new count is from server process name, and then of course a little helper just so that Blazor refreshes. And so if I run the application again, which we never really shut it down, go to counter, click. See, this is my server process, and 5 is 2 more than 3. But why is it 2 more than 3? Where is that math taking place? Because it's not taking place here. It's not being handled here. All the client code is doing is sending. Well, let me control B into this send method, which is actually only in the interface. Okay, this is in the interface, but control Alt B to jump into the implementations. We have 2 implementations, and they're actually both in the shared library. We have some options here, but we need to figure out which one we're using on the client side. That's where in our program CS, oh, wrong one. This program CS, we are using Remotable Bus. Okay, so if we come back here and Control B to Remotable Bus, this is the one that's active in the browser in our WebAssembly application, and it's remotable. Why? Because it has this extra dependency, Publisher Gateway. And so look at this little bit of logic. If the request is of type iRemotable request, then let's take that request, all right? Let's take that request as a remotable request, and let's go ahead and publish it to the gateway, all right? And of course, if getting back the web service message from the gateway is null, we throw an exception because it needs to be something. And we're going to get this result, and then we're going to get the body object, casting it to whatever we need it to be, and then we're going to return it. Okay? So if we're going to jump into publish, let's Control Alt B into here. Of course, this is a pretty straightforward class, but we notice that we have a constant called API relative URL. All right, so our publisher gateway is actually going to own in one single place the URL, which is, for this purposes, this is our connection string. This is our single connection string. And if we look for usages, we have a few usages. One of them is actually in our API controller. And the API controller is saying, hey, I'm going to be at this connection string, at this URL. All right, going back to it. And so in publish, we're going to take the request. We're going to put it in the envelope of our web service message class. And then we're just going to send it. Okay. And send to topic, you can call it whatever you want. I just wanted to refactor this out. And we're going to do a little bit of massaging. I'm not going to go through all this. We're going to post it as JSON. We're going to munge it into the HTTP client. And then when we get back some JSON, we're actually going to deserialize that JSON back into a web service message. And there it goes. Okay. So at this point, let's look at what web service message does. Because if you remember, when we actually click here, we have a call, and the payload is just the count of 4. Okay, that's what we're sending. And we're also sending a type name string so that we have the fully qualified type name so that there's no ambiguity there. And then our response, this is the web service message serialized into JSON. And while it actually uses binary in Azure Service Bus, everything is serialized into some sort of format to go over the wire. So if we come here and actually put some different JSON in here and then open that in the JSON viewer, coming back is a body of new count is 6, server process name is yada yada dot server, and then of course the type name that's coming back so we can deserialize it properly. Okay, so it's just JSON on the way back stuffed into a envelope of web service message. Okay, so let's look at web service message, because this right here is really important. This is not provided to us by Microsoft, but it's a simple pattern, and really I got a lot of inspiration from the Service Bus message class. So just looked at that code from the Azure Service Bus SDK, and noticed that it has a few methods for serialization and deserialization. Get body, we're calling JSON serialize system.text.json. We're calling serialize here, and we're calling deserialize here. That's really what it is. It's serving as the envelope to take a type, convert it into JSON, or have the JSON and then deserialize it back into a particular type. But this is our envelope. So the only type that is going back and forth between our WebAssembly code and our web API is this web service message class. Every command, every query gets stuffed into this envelope for transport. Okay. Now let's look at some of the things that we're doing here. If we look back in our shared library, we have the default weather forecast data, additional forecast data, which I didn't put anything in, but the date, the temperature, the summary, this comes straight from the template. Okay. Then we have some queries. We have forecast query, which is a very simple class. It's basically just, hey, give me the weather forecast array, or give me the weather forecasts. It's a question, right? So in a lot of cases, we don't have any parameters, so we don't have to have any properties. The counter query does have an initial property, which is the initial count. And then server info query is, hey, give me the server info. And I'll show you what that is in a second. And then the additional forecast query is just the ID of what we clicked on. And the update forecast command, which when we updated it, is giving the ID of what it is, and we're actually getting information back. So let me demo again, and we'll go through these. So on the home, this is actually the server info. I said, hey, give me the server info, and we're displaying it on the screen. And so in the index page, literally, I'm just displaying whatever I get back on the screen from sending a server info query on the bus. And again, this is only one web service API. I'm just asking for the server info. And then on fetch data, I didn't show you this earlier, but there is actually an update button, and it clicks here, and we are saying bus.send new update forecast command with whatever I selected. Okay, so if I go here, load something, and select on this one that says freezing, click. Now we have that update, and it's updated. Okay, and it called over to the server. All right, so we still haven't gotten to the handlers. Where's all this stuff happening? Well, it's happening in the server project. Okay, we are calling bus.send. If I go into here, again, it's our interface, but on the server, I'm using bus, not remotable bus. Well, how do we know? Well, we can go to our program.cs, and for web services and whatnot, there's more stuff than is just in a WebAssembly application. But looky here, we're in our DI container, we're adding bus to satisfy the interface iBus. Okay, all right, so that's key. Okay, so we are receiving bus.send. We are receiving these, and we're just delegating it to Mediator. And Mediator, I won't talk about. If you've never heard of it, go look up the documentation. It's going to route it to handlers based on the type. So let's review. If the type, let's go to counter query. If the type is of iRequest of server count, then we need a handler that can handle that. I just happen to know where these are in the server project. There's handlers, counter event handler. Or actually, this is named improperly. This counter query handler. The wrong file name. Look at that. Okay, it is a request handler for counter query that knows how to return a type server count. And so it's receiving it. It knows what to do. It's going to look at the current process, grab the process name, and is going to return a new server count of 2 plus whatever the incoming count was and the process name. So that's where our math is happening. We're adding 2, and then we're just returning it. That's it. So remember, when we were on the count page, I clicked, and this is always going to be 2 from what the one in process. So no matter how many times we click it, it's going to call over to the server, and it's going to be more than 2. And every time, it's going to call to the server. Super quick, but it's going to call to the server. 28 was here. Payload, 28. Response is 30. Okay, there it is. And again, it's the same URL, the same URL. Okay, so now let's review the diagram again. With Blazor server side, Microsoft gives us the single transport where so many reasons to call the server, every message goes over the single transport, whether it's the WebSocket from blazor.js to the server for Blazor server side, or if our code is calling over to SQL Server with one connection string, one address, lots of different queries, Microsoft is giving us that one way, that one address to call to the server. With Blazor WebAssembly, we need to implement our own pattern in order to get to that one address to call over to the server. This pattern has me really, really excited because Blazor applications are quickly becoming the new normal application type. And we're going to be running more and more Blazor WebAssembly applications in the browser. They're going to need to call various web services. And so many times, the web services they're going to call is going to be our code that just needs to be on a server somewhere that's closer to our data sources. These web APIs, these web services are not public web services that need to be documented and secured so that we can give our customers or other people or even other teams access to it. It literally is a private web service. Think of public methods versus private methods. These are private web services, and they should only be called from the Blazor WebAssembly application that is paired with the server side part, okay? And so we don't need all the ceremony of Swagger and all that goes into publishing and maintaining web service contracts and all that. We just need some private methods that happen to be remotable. HTTP is a great way to do it, but not if we end up creating hundreds of these web API controllers, because it's a bunch of ceremony and it doesn't give us any architectural benefits. And so we can draw and borrow from the patterns that SignalR SDKs use, that Azure Service Bus SDKs use, that the SDKs to call to SQL Server and other database. We can borrow those same patterns and implement a pattern to create an envelope that our data and our requests stuff into for the purpose of going over the wire to those components that are on a different machine. And we can do that in this case as well. And then when it comes to implementing new screens, new capabilities in a Blazor WebAssembly application, instead of having an additional step of creating a new web API controller on the server side, we have no more ceremony than if we were to use a Blazor server-side application. And you know, a lot of the initial differences when choosing Blazor server-side and Blazor WebAssembly is on developer productivity. And Blazor server-side has had one more notch on its belt for productivity because it has fewer concepts. You can create a screen, immediately call over to a database, and you're done. It has fewer steps to get new functionality working. Whereas Blazor WebAssembly, you created the screen, but then you had to do some extra code to jump over the wire, and then you call your database, and there's that extra ceremony. Once you have implemented this pattern for your team, once you've done it the first time, that additional ceremony is literally gone. There is no difference in number of steps to implement a new screen with Blazor WebAssembly than there is with Blazor server-side. So the productivity curve becomes identical, but at the same time, you get the benefit of using your client's CPU and your client's memory instead of Blazor server-side, which uses all the server-side memory. And so your server-side processing footprint becomes really, really small. You're only running web services on your server and then calling over to whatever data stores you have. So I'm really excited about this pattern, and I encourage you to grab the code, download it, and test out this pattern for yourself of creating Blazor WebAssembly applications with only a single web API. God bless. Thanks for programming with Palermo.
You've been watching Programming with Palermo, your primary place for highly productive programming protocols and practices. Remember, you have what it takes. You can do this. You are a programmer, formed by God Himself and called to this profession for a purpose. You can catch every episode at palermo.network as well as syndicated locations nationwide. We're so glad you tuned in. Until next time, may God bless you, and thanks for Programming with Palermo. Programming with Palermo has made a special arrangement with Marketplace Chaplains. Besides programming challenges, we all face issues in life where we need some help. If you'd like, you can call a chaplain confidentially. To speak with a gentleman, dial 512-923-8178. Or to speak with a lady, dial 512-619-6950. The show won't know you called, and everything is kept in strict secrecy. This is a free service, available if you or a friend need it.